Hello, and welcome to my project presentation titled Pollution in Prey Predator Dynamics using Netlogo. Ecosystems are
An area where plants, animals, and other organisms, along with the physical environment in which they all interact. They provide habitats to animals and plant life, and promotes a variety of food chains and webs. The role of ecosystems can be defined in major services. Provisioning services, the products obtained from the ecosystem such as food, water, and fuel. Regulating services, the services that benefit from the regulation of ecosystem processes such as air quality, water quality, and purification. Cultural services, spiritual and recreational services that people obtain from ecosystems such as cultural diversity, spiritual and religious values. Supporting services, the services that are necessary for the delivery of all other ecosystem services such as soil formation and nutrient cycle. Recognizing the importance of ecosystems is vital for sustainable development in being responsible to the environment. It is also vital to not only protect and conserve, but to also restore to the various ecosystems since they are crucial for the maintenance of the services and that they provide that is essential for a greener and healthier planet. Environmental pollution is not a new phenomenon, yet it remains the world's greatest problem facing humanity and the leading environmental causes of morbidity and mortality. Pollution can come in many forms such as soil contamination, water pollution, air pollution, and chemical waste. These pollutants are products of agricultural practices, urbanization, industrial waste, and other human activities. The effects of pollution also extend to people where it can cause physiological disorders. Understanding how pollution affects the ecosystem and its organisms will help develop efforts in mitigating it and creating sustainable practices that help in restoring and conserving natural resources and health. And shown below is the ecosystems as its chart. For the equation-based model, we use the Lotka-Volterra model, named after Alfred James Lotka and Vito Volterra. This model assumes that the prey consumption rate by a predator is directly proportional to the prey abundance. This means that predator feeding
is limited only by the amount of prey in the environment, and shown below are the formula used by this model, with the first one used by the prey, the second one used by the predators. Now we go to agent-based model. The agent-based model are created and implemented in Netlogo's modeling environment. The Netlogo world is a two-dimensional that is made up of a different number of grid cells referred to as spatials. Agent-based models and stochastic end results would differ slightly in each model that are simulated. The simulation will have two models, namely the prey-predator and prey-predator grass. In the flow of the simulation, the first one to start is the selecting the model type. The simulation starts with selecting which of the two models is to be used. In the first model, the greenery will not be modeled to be consumed by the prey, and no chance of pollution, while the predator will have to hunt down the prey in order to gain vitality or else die from starvation. The second model is almost identical to the previous one, except that the greenery will be consumed and can be polluted. This time, the prey must also eat the greenery in order to replenish their vitality or die. The greenery will regenerate, in fact. And shown below is the drop-down menu that you can select from the program. Second is modifying the agents. The simulation will let you tailor the prey and predator settings, such as its initial population, reproduction rate, and shape. Also included are the regrowth speed of the healthy greenery, how strong the pollution is, and can be toggled if there will be pollution or none. The settings for the display of vitality can all be toggled on and off. Running the simulation. Once the modifications of the agents are finished, the initialize button must be pressed to initialize the settings made before, and selecting start will make the simulation move forward. The simulation graph will monitor the number of prey, predator, and both healthy and polluted greenery. The simulation only stops if prey, predator, or both are dead. And its limitations. Since the model runs on assumption, simplified representation could not represent the complex real-world ecological factors that influence prey-predator relationships. The lack of individual agent variability, such as behavior, adaptability, and physiology, can create an incomplete understanding of prey-predators' response to pollution. And shown below is the flowchart for the project, where we first modify the agents, and the agents start moving. They are prey and the predators in range. They might die, not they live. But if they die, they'll be removed. And if there's no predator, they eat the greenery and gain vitality, and they reproduce. So it's the same for the predator. Is the prey in range? If yes, they can kill the prey and gain vitality, and they can reproduce. If not, they'll die from starvation and be removed. Results and discussion. The simulation model using Netlogo was employed to study the effects of pollution in prey-predator dynamics. The virtual ecosystem of the model comprises of two types of agents, namely prey and predators, with the prey generally consisting of species of herbivorous creatures and the predators as their natural hunters. The results reveal several interesting insights and patterns. In the absence of pollution, the population of both prey and predator are almost stable, thus representing a stable ecological balance. However, once pollution is introduced to the simulation, the ecosystem's balance starts to change. The prey gain an increase in population, but then declines once the healthy greenery declines in numbers, and are forced to eat polluted ones. Predators are of the same situation, as they increase their population before declining due to lack of prey. The simulation we use presents results that highlights the complex relationship of pollution with the prey-predator dynamic. Its introduction to the model disrupted the virtual ecosystem's balance by affecting the health of the prey and their survival. By affecting the population of prey, it also affected the predators, leading to their decline in population. Pollution is a factor in the prey's population decline. Pollutants can contaminate plants, and reducing their nutritional value and increasing the prey's mortality rate. It can even affect the health of the prey directly. The insights provided by the simulation stresses for the for including pollution in the understanding of prey-predator dynamics. Failing to do so may fail to highlight the consequences of ignoring its impact to the ecosystem's functions. Having the simulation helps in any authorities and conservationists' efforts to evaluate and develop strategies to counter its adverse impact on the ecosystem. And shown below are the graph, with the left one showing for the no pollution graph, and the right one showing for with the polluted graphs. Conclusion and recommendation. This study made use of a Netlogo simulation model to investigate the effects of pollution on the prey-predator dynamics, and the results highlights its effect on the population of both predator and prey. The introduction of pollution led to the decline of the prey population and in turn the predators, primarily in its adverse health effects and reduced food quality. The findings also emphasize on pollution as a critical factor in understanding the complex dynamics of the ecosystem. Thus, ignoring the impacts of pollution is detrimental to understanding the ecosystem and developing strategies for environmental management by policymakers and conservationists. Future studies can enhance the prey-predator model by including more complexity into the model. This includes multiple predator and prey species in the model. By simulating a more realistic representation, the model can provide more accurate insight on pollution's effect on the ecosystem. Also introducing specific species traits such as vari-
Uh, Varying behaviors and responses will allow for a more refined understanding on how pollution impacts ecological systems. And that is for the PowerPoint presentation with my references. And now we head to the simulation program. Here, on the left side, are the prey and predator settings as said in the PowerPoint with the population, food gain, production, and the shape. Below them are the pollution settings, the pollution intensity, and the pollution factor. Here is the patch, and here's the selection for the variation of the model with the prey predator and the prey predator grass, with the greenery regrowth factor and the polluted greenery regrowth, and the vitality and the initialize. Now we will initialize the settings with 100 population of prey and 50 population of predator. And we will select the prey predator grass and start with no pollution. And now we start. So as you can see, a stable balance in the ecosystem. Now if we go to with pollution and start, and in here the model shows that both populations died with the predators as the last one standing, or the last one that had died, because the polluted grass killed most of the prey or has driven the prey away from the area, and so the predator also has to move or had died out from the lack of prey. Thank you for letting me present my final project, and thank you, Sir Irvin, for teaching us and guiding us in our activities and projects. And to you, my classmates, thank you for our camaraderie and assistance to each other. God bless and thank you.